Good morning, everybody. So this webinar from me today is about drying litter before chick placement. Felicity mentioned heating, but we'll also look at airspeed and litter tilling as well and see what effects that has on drying the litter. Before I get too carried away, I just need to acknowledge AgriFutures and the Queensland governments for funding and supporting this research. And thank you to the growers who provided us with litter samples and with information and their ideas throughout our project and all the other research that we've done in the past. So why do we need to dry litter before placement? Well, it's to make sure that the floor is nice and warm and dry for the day-old chicks. They're the priority. Drying the litter out will remove any leftover moisture or ammonia, hopefully, from the floor or the litter. It increases the water holding capacity of the litter during brooding and will save on heating costs because you're not going to be losing or using heat to try and keep your floor warm, or not as much heat. So what things are required to evaporate water from the litter? First of all, the moisture in the litter itself needs to be at the surface. So bringing it back to the surface will help to evaporate more of it. Heating the litter and the air will help to evaporate water. Using airspeed, the more airspeed, the more water will be evaporated from the litter. And having air with low relative humidity gives it the capability to actually absorb the water from the litter. So we need all four of these things to be working in our favour. But what does this all mean? If we're trying to dry the litter, should you be turning on more fans or using circulation fans, turning up the heat, tilling the litter? And how will the weather in your area at the moment affect the way that the litter is going to dry? So I'll go through a few of these things now. So firstly, bringing the moisture back to the surface. So when the litter's all well mixed, the water's evenly distributed through the litter. But as we take the water off the surface with drying, the surface becomes dry and it acts like a blanket sitting on top of the litter. And when that happens, it actually stops the water from being able to move from the litter and into the air. So stirring up the litter and bringing the wet litter back to the surface will help to remove more of it. Without moving the litter and without stirring it, the drying rate is reduced. From some experiments that we've done, we found that after about 4 to 6 hours, the amount of water evaporation reduces by about 40%. After about 12 to 15 hours, it reduces by about 70%. So your drying rate's only about 30% of what it was at the start. And after 24 hours, the drying rate is reduced by 85%. So instead of evaporating a litre of water off the floor, you're only going to be evaporating about half a cup off the floor after 1 day if you don't stir it up and bring that moist litter back to the surface. So it's time to get things out and stir them up. Adding heat to the floor is also very important. First of all, it reduces the relative humidity in the air. So the general rule of thumb is that by increasing the air temperature by about 10 degrees, reduces the relative humidity by about half. Warming the air will also warm the litter. And as you know from your broiler handbooks, there's recommendations to preheat the floor to about 30 degrees at least 24 hours beforehand to make sure that the floor is warm and dry for the chicks. And by warming up the litter, you actually help it to evaporate water from the litter. It frees the water up to move into the air a lot easier. So heating the air will reduce the relative humidity. And what we're targeting is a relative humidity of less than about 50 to 60%, so that the air's got the capacity to absorb the water out of the litter. But once the moisture's moved into the air, it's critical to actually ventilate that out of the shed. Otherwise, the humidity in the shed's just going to increase. So we've got to warm the air up so that it can absorb the water from the litter, and then we've got to ventilate it out of the shed. Airspeed at the litter surface has quite a strong effect on the evaporation rate as well. But one of the challenges that we have with the meat chicken sheds in Australia is that the airflow in the shed is generally driven by the exhaust fans. So if you're trying to create airspeed in the shed, particularly if you're running heaters, you're not going to be inclined to want to use the fans because all you're going to do is exhaust all the warm air out. One way to conserve that heat is to use circulation fans within the shed itself. Mike Zarek and the team at the University of Georgia have been developing and evaluating a system of circulation fans to generate air speeds of about 0.8 to 1 metre per second within the shed itself. And this will be very useful with drying the litter. Circulation fans also help to bring the heat down. So when you're running the heaters and the hot air goes to the roof, using circulation fans brings that heat back down and actually makes use of what you're paying for already. So now I just want to consider a situation here. So just imagine that you've received a load of damp bedding as you're preparing to set your sheds up for placement of the chicks. So the picture here shows absolutely soaking bedding, but we'll use an example of about 30% moisture content. So I guess some questions here is how dry do you want it to be? And then how long will it take to become that dry? And what could you do perhaps to make it dry out a little bit more quickly? So first of all, for the target moisture content, I'd suggest targeting about 15% moisture content. There's going to be two reasons that I'm going to suggest this. First of all, it gives the litter the capacity to absorb about 1.2 to nearly 4 litres or a bit over 4 litres of water per square metre. And that's the amount of water that the chickens are going to place on the floor in the first 4 to 7 days. So if you can get the litter dry before you put the chickens in there, you can then focus on ventilating for the chickens rather than having to try and evaporate water or focusing on evaporating water from the floor. Getting the litter dry will also help to save energy for you as well. So at 15% moisture content, the amount of heat required to maintain the floor at 30 degrees is going to be the same as running one of the space heaters for about 70% of the time. If the litter's a bit damper, so at about 25%, you have to run about 1.3 heaters constantly just to keep the floor warm. And if the litter's even wetter than that at 35%, you'll be running nearly 2 space heaters constantly just to keep the floor at 30 degrees. Because there's so many factors going on, we're talking about airspeed and heat, and then we've got tilling of the litter. It's very difficult to try and guess how much or which one's going to have the biggest effect. So I've come up with a bit of a spreadsheet here which helps me to calculate the effect of making some of these changes to airspeed, heat and litter turning. So what I'm going to start with is an example where the litter's about 30% moisture content. We're going to target reaching 15%. And what I've chosen as a normal procedure, I think, is the minimalist sort of approach. So no extra heating and having an airspeed in the shed of about 0.5 metre per second, which would be the same as running a few of the fans. And then we'll look at a few alternatives. So adding some heat, using and creating more airspeed, and also tilling the floor. So let's see what this does for us. Before I do that, I guess I'll just have a whip around the country. I got some weather data from a couple of days ago in a number of the growing sites that we have around the country, the regions. So let's see what just the place where you are in the country, how that affects the drying of the litter. So this is the sort of chart I'm going to be looking here. We've got moisture content. So we're starting at 30%, and over time, the moisture content's going to reduce because the floor is going to start to dry out. And over here, we've got the weather conditions. So this is one day. The orange line is the temperature. The blue line's the relative humidity. So I don't know if it was perhaps a little bit humid in Perth a couple of days ago or whether this is normal for this time of year, but basically the floor didn't dry out that much. It went from 30% to 25%. Moving across to Murray Bridge in South Australia, much lower humidity. The maximum humidity here was the minimum that it was at Perth. And not surprisingly, we're seeing the floor drying out. So when we look at these lines, there's a fair drop right at the start here, and that's because initially the litter's sort of stirred as you spread it out on the floor, but then after a day of drying, that evaporation rate decreases. These flat parts here are during the night, and the steeper parts are during the day when the relative humidity is lower and the air's a bit warmer. So that's the kind of effect that it has, the weather will have on the drying of the litter. And in Murray Bridge, we managed to reach our target moisture content of after about 6 days. In Tamworth, and this was sort of similar for Sydney, more humid, and we didn't reach the target temperature. Brisbane, very similar. Up north Queensland, we don't really get high humidity, don't get low, it's just sort of average with nice warm temperatures, but we still didn't manage to reach our target temperature. And this is the last one, so we go to Melbourne, and surprisingly, it's sort of about the middle of the range compared to most of the other sites. So I'll use this for some of the examples where we look at different airspeed and heat. But once again, without doing any extra practices in the shed, the litter didn't reach the target temperature that we were after, target moisture content, sorry. So first of all, let's look at increasing the airspeed. So we started with 0.5 metre per second, which is running a couple of fans. Let's see what happens when we increase that to 1 metre per second. We can see that the litter becomes drier, but it still hasn't reached the target temperature, target moisture content after a week. We increase it again to 2 metres per second, so you'd be locking the shed into tunnel ventilation mode and just turning a good amount of your fans on to do this. And we reach the target moisture content after about 6 days. We turn all the fans on, we've got the shed running flat out. Let's assume we get 3 metres per second at the floor. We can dry the floor out and it takes about 4 days. So we have to turn a fair few fans on to get the litter to dry out. Let's add some heat now. So in Melbourne, it was fairly cool. The daily maximum was 20. The minimums would look like they were about 5. So if we set the thermostat, add a bit of heat. So let's use 15 degrees Celsius. So we're not making the shed hot, but just stopping that nighttime cold air. We can dry the litter out. It's quite effective. We add a bit more heat. Let's use a minimum temperature of 20. And we're drying the floor out in about 4 days. If we turn it right up to 30, which is where we're going to have the shed before we place the chickens, it reduces the time to dry to the target moisture content to about just over 2 days. So adding temperature is quite effective. It looks like it's more effective than using a lot of airspeed. Tilling the litter revives that evaporation rate from the litter because you're bringing the wetter litter to the surface again. So without any tilling, we have this decline at the start of the time, and then it sort of plateaus out because we've got a dry surface and the moisture can't get to it from the deeper parts of the litter. By turning the litter after a day, we then can evaporate more water off the floor. So this one here, the first red line there is turning the litter at 4 o'clock the next day. So it's 4 o'clock in the afternoon. So heading back into night, what we find is that the evaporation rate decreases. And so, it's effective, but you don't get a lot of evaporation rate for too long. If you turn the litter earlier in the morning and you get the full day of drying, you actually get dry litter at the end of it. So it's the same investment of time for you to jump on your tractor and till the litter. But if you till the litter in the morning rather than the afternoon, you're going to get dry litter. If we go crazy and turn the litter every day, we can reach our target moisture content. And we can see these big drops in moisture content every time that we turn the litter. So we've looked at practices on their own, but what happens if we start to combine a few of these? So in the first one here, I'll assume that we add a bit of heat. So we're going to heat the shed to 20 degrees or have a minimum temperature of 20 degrees. I actually reduced the airspeed here because I think if you're going to turn the heaters on, you're more likely to turn some fans off to try and retain that heat. And we'll just turn the litter once. And by doing this, the moisture content reaches the target in about just under 4 days. If we keep the same conditions but turn it twice, we shave a day off the drying time and bring it back to 2.5 days. Let's turn the temperature up a bit. So same airspeed, one turn, 25 degrees. We're at about just over 2 days, so it's even quicker. And the last combination that I looked at was turning the airspeed up. So this might be, you'd have to use something like the circulation fan system that I showed before to try and create airspeed within the shed. And this is assuming that, of course, you're going to ventilate the humidity out of the shed once it starts to increase. But by adding a bit of heat, adding airspeed to the floor, and then turning the litter so that the wet litter can come to the surface, we can shorten the drying time substantially. I guess the conclusion is that there's no magic combination to get the litter dry quicker, and the options that you might choose will depend on the amount of time you've got available, the equipment you've got on the farm, and the cost of your utilities, how expensive your electricity is and your gas is. And that might determine whether you want to use more airspeed or use more heat. But the takeaway message is that using combinations of all of these things is what really accelerates the drying of the floor. So adding a bit of heat, increasing the airspeed, and stirring the litter up is what really gets the litter dry. And that's it for me for today. Thank you very much for your time. If you'd like more information, please contact me. And there's a few links here with some videos on the Extension Oz website about relative humidity and preheating the litter. And there's one of Mike's poultry housing tips about drying the litter as well, preheating the floor as well. So that's it for me. Back over to you, Felicity.
Thank you, Mark. I'll just give people a few minutes to type in some questions. If you'd like to type in some questions for Mark in your Q&A section. You've done such a good job, Mark. Everyone's got the message and clear as crystal. Here we go. Mark, can we see you and unmute you for the questions? Thank you.
There we
Mark,
go.
We've got a question about how can you measure moisture content in litter?
Okay, so the way that we do it during our experiments is to dry the litter out and weigh it. So we weigh, and that tells us how much water there is in some litter. There's a litter assessment tool which is available. You can get in touch with me or the organisers of this webinar, and we can send it to you. There's ways to sort of guess how, or to estimate how moist the litter is by the way that it feels and the way that it, how dusty it appears and that sort of stuff. So you can do it physically, and that's probably a more useful way than trying to dry the litter out and get an actual number. So.
Thanks, Mark. The question's starting to flow in now. Mark, do you see extra advantage by moving to the lower litter moistures?
The advantage, well, there's several advantages. Like I sort of come from an odour background, and having dry litter tends to produce a lot less odour. From the animal welfare perspective, it's, I think, pretty well accepted that having dry litter generally produces less of the contact and foot pad dermatitis, so there's benefits from that as well. Having super dry litter when you're placing chicks may be an issue with dehydrating them, but it's probably less of a concern than having wet litter that you've then got chicks sitting on wet litter and feeling cold. So it's probably better to go on the dry side or aim for the dry side, because if you run out of time, at least you're going to get most of the way there.
Okay, thank you. Will the experiment somehow relate to drying litter with peak density birds in sheds?
Good question. Thanks for asking. That's where we're heading. We've got another spreadsheet sort of in development at the moment where we've got the water from the birds going onto the floor as well. And we're also incorporating shed ventilation data so that we'll actually have a much better estimate about airspeed, water removal from the shed, and the amount of water that the birds are putting on. So it's going to be a more of a water balance for the litter. So that's our next stage. And we're hoping that that'll give us a better idea of when challenging times are during each day, during the batch and during the year at different sites around the country, so that we can hopefully test out some different drying strategies.
Thank you. Mark, you mentioned 15% litter humidity is close to ideal. Do you see any advantage of going lower than that?
I think you'd struggle to go lower than that. Just because of the way that water absorbs or balances out between moisture, relative humidity in the air and the litter. With normal sort of relative humidity, if you say it's an average of about 50%, the litter will tend to dry out to about 10 to 15% anyway. So I wouldn't go lower than that, otherwise it's going to be too dusty and too crispy. That, I don't know, 15% I think is pretty well fine.
Thank you. Mark, thank you. That was fantastic information. Did you look at types of equipment, that is variations in equipment used to turn litter? And did you also look at the physical techniques of turning litter, for example, the directional methods of the turning? We
haven't looked specifically at the machines. We've just made the assumption that the machines exist. And seeing a few in operation, they tend to do a reasonable job. I'd like to see the litter. So when you're running the machine through the shed and you've got wet and dry litter, I'd like to see all of that well mixed together. And some of them don't tend to do that so well. You still end up with wet litter in one line and dry litter in the next. The better that you can mix the wet and the dry together, the better it is, I think, because you're trying to get away from the threshold where the litter will start to cake again. So I think if you're looking for a machine, get one that's definitely going to be mixing the litter over the width of the machine to mix the dry litter in with the wet litter.
Thanks, Mark. Are there any concerns with bacteria, mould or fungus growing in wet litter?
I think definitely. I think everyone would accept that having wet litter is going to make it more susceptible to having mould and bacteria. The water activity in wet litter is higher, and that's one of the essential requirements for food safety pathogens and disease pathogens as well. So by getting the litter down to 15% moisture content, the water activity is far below the water activity required for most of those organisms to exist. By the time you get to sort of 25, 30%, you're really back in the stage of being able to grow mould and fungus and bacteria. So by getting the litter down to 15%, you're going to really be slowing down any development of the mould and fungus and bacteria in the floor.
Thank you. Do the drying times change with different litter material, and which one is better than the others?
What we've sort of found, there's a bit of a difference in the water holding capacity of different materials. So pine shavings, for example, will hold less water for the same area than sawdust. And that's just because there's less material in it. There's a lot more air. Hardwood will actually hold a lot more than pine sawdust. And it's just because it's a denser material, so it can actually hold more water in the area. So from a drying perspective, what we find is that the more water there is, the more water that evaporates off. It will take longer with sawdust than it will with shavings, and hardwood will take longer to dry than pine just because there's more water there at the same moisture content. Reused litter as well, if you're using reused litter, it can hold even more water again still. So they will take longer to dry out than pine pine shavings or sawdust. I think the data that we're working on, I think we've sort of used pine sawdust because it's about the mid-range.
Thank you. If using stirrer fans rather than exhaust fans, how do you remove the moisture released in the air? Or do you recommend a combination of both?
It's definitely got to be a combination of both. So the sheds will have the exhaust fans on it. You need them anyway later on. The stirring fans we're talking about are additional. So you'd use them at these times of the batch, at the start of the batch, when there's not a lot of airflow. And it's, you know, as the other fans turn on later on and they're running constantly, you then get the airflow. But until that time, having circulation fans helps to keep the air moving within the shed, helps mixing the ammonia and diluting the ammonia within the shed and moisture, and also brings the heat down to the floor where you can actually use it to do what it's supposed to do.
Thank you. And Mark, last question for the moment. How much of the shed can have wet litter and not be considered a problem?
I don't think there's any magic answer to that. I've sort of seen from experience that if you had about 20% of the floor, you know, a little bit wetter, a little bit cakier, so under the drinkers, I don't hear about anyway there being increases in the footpad dermatitis. I'd love to get data that could actually sort of show that. I don't think there's any specific answer that's available at the moment.